Welcome back. In the previous lesson, we finished off input devices when we looked at touch screens. We're now going to be looking at output devices, especially what they are and why they're required. However, we're not going to go through a group of output devices per lesson. In this one, we're going to cover them all. So this will probably be a slightly longer lesson than some of the previous ones. However, we should be able to cover all of them in one go. So let's begin by looking at the type of output devices you need to know for the exam. You need to know about the actuator, the digital light processing projector, inkjet printers, laser printers, light emitting diode screens, liquid crystal display projectors, liquid crystal display screens as well, speakers, and a 3D printer. Let's begin by looking at what output devices actually are. How do you define them? So output devices are hardware which are used to send data out of a computer system. Once data is input, it is processed by the CPU or the microprocessor. It is ready to be sent out and shared with everybody else. And output devices can be temporary, like the monitor, or permanent, like printed hard copy. So they can be two types. Temporary output is refreshed and changes regularly. So the image on your screen changes as you move your cursor, perhaps, or start a new application. However, permanent output cannot be changed once this output. So the printed piece of paper, the 3D printed object will always stay the same. Okay, let's get straight into actuators. Actuators are used in many control applications, especially those that involve sensors. When the computer is used to control devices, there's normally a motor or a valve, and it is necessary to use a digital to analog converter since these devices need to convert digital data to analog data, which influences the real world. Now, these are the opposite of input devices, which need to take analog data and convert it into digital data. Here we go the other way around. Now, an actuator is used in these control applications, and that's the main component. So what is an actuator? Well, it's an electromechanical device such as a relay, solenoid, or motor. You can see some of those examples on screen. Now, the solenoid is an example of a digital actuator because part of the device is connected to a computer which opens and closes the circuit as required. So we don't really give this one as an example of an actuator. However, they are still actuators. Now, when energized, the solenoid may operate a plunger or a metal bar or an armature to control, for example, a fuel injection system. So these digital solenoids are used in conjunction with actual analog devices. Other actuators such as motors and valves, they definitely require a digital to analog converter. So they receive an electric current rather than a simple digital signal direct from a computer, because a motor does not understand a digital signal, but it does understand the analog current. So there needs to be an additional device called a digital to analog converter, which takes the digital signal from the microprocessor and converts it into electric current, which perhaps a motor or a valve can actually understand. So make sure you remember this component. An actuator is an electromechanical device, such as a relay or a motor or a valve, which needs a digital to analog converter to convert a digital signal to an analog signal, so it can actually influence the real world. It's the output part of a control system. Okay, let's leave actuators there and move on to light projectors. Now, there are two common types of light projectors: digital light projectors and LCD, liquid crystal display projectors. Projectors are used to project computer output onto larger screens or even onto interactive whiteboards that you perhaps use at school. They are often used in presentations and in multimedia applications and even for entertainment. If you go to a cinema, chances are there's a massive projector at the back which is projecting that huge image. Now let's start by looking at digital light projectors. These use millions of micromirrors on a small digital micromirror device chip, which is key to how these type of projectors work. When the micromirrors tilt toward the light source, they are on. When they moved away from the light source, they're off. This creates a light or dark pixel on the projection screen. Now on screen, there's a little diagram that explains the process. So perhaps you might want to pause and have a look at that, or you might listen to how the process works. What happens is a bright white light source, which is normally a xenon bulb, passes through a color filter on its way to the DMD chip. The white light is split into primary colors, red, green, and blue. The DLP projector can create over 16 million different colors as a result of this. The DMD chip is a micro opto-electromechanical system, MOEMS. That's because it's a microchip which uses light, hence the opto. It converts that into an electrical signal, hence the electro, and it tilts, and that's the mechanical part. Now, it contains several thousand microscopic mirrors, which are normally made out of polished aluminum metal, and these are arranged on the chip surface. These are very small. They're about 16 picometers, which is 16 times 10 to the minus 6 meters in size, and each corresponds to a pixel in the displayed screen image. So the final image quality is far superior to older technology like LCD projectors. Now, these are older technology than DLP. What happens with these is that a high intensity beam of light passes through an LCD display and then onto a screen. You can see that image in the top right hand corner. That visualizes the key principle of operation for LCD projectors. So you've got a powerful beam of white light generated from a bulb or LED inside the projector's body. This beam of light is then sent to a group of chromatic coated mirrors. These mirrors reflect the light back. When the white light hits these mirrors, the reflected light has wavelengths corresponding to red, green, and blue light components. These three different colored light components pass through three LCD screens, and these screens show the image to be projected as millions of pixels in a grayscale. The light passes through the LCD screens and a red, green, and blue version of the gray image emerges. These images are then combined using a special prism to produce a full color image. Finally, the image passes through the projector lens onto a screen. So this process is very complicated as the underlying technology is very old. So what do you really need to know about projectors? Well, you need to know the pros and cons of both types of projectors. So DLP projectors have higher contrast ratios. They have higher reliability because they have less moving parts. They run quieter. They use a single DMD chip, which means there's no issues lining up the images. They're smaller and lighter than LCD projectors. They're better suited to dusty or smoky atmospheres, which might interfere with light projection. However, their disadvantages are that the image tends to suffer from shadows when showing a moving image. DLP images do not have any gray components in the image, just colored ones, and their color definition is frequently not as good as LCD projectors. LCD projectors, on the other hand, give a sharper image than DLP projectors. They have better color saturation and definition. They're more efficient in their use of energy than DLP technology. Consequently, they generate less heat. However, the disadvantages are that their contrast ratio is not as good as DLP, and their longevity is lower than DLP because they use a bulb which has a limited lifespan. And since LCD panels are organic in nature, they tend to degrade with time. So screens turn yellow and the colors are subsequently degraded over time as well. That's all about projectors. Let's move on to printers now. There are two types of printers we're going to look at. The first one is inkjet printers, and these are essentially made up of a print head, which consists of nozzles which spray droplets of ink on the paper to form characters. This ink is provided via a cartridge or a combination of cartridges. You can have all the colors in one, or you can have a single black cartridge, or ones for yellow and magenta, and a combination of up to 6 colors is also possible. There's a stepper motor and a belt which moves the print head assembly across the page from side to side, and a paper feed which automatically feeds the paper as required. So what are they used for? Well, they're used for high quality printing. When you want as few pages or photographs, chances are that you would use an inkjet printer. They're cheap to buy and they have a small size. That's the benefit. Their color reproduction is far superior than laser printers. However, the issues are that they use expensive ink, which can run out and often cost more than the printer itself. The size of the ink cartridges and the paper tray is often very small, and these tend to be very slow as well. Now, the ink droplets that these printers produce can come in the form of two different technologies. First is thermal bubble. Here, tiny resistors create localized heat, which makes the ink vaporize. This causes the ink to form a tiny bubble. As the bubble expands, some of the ink is ejected from the printhead nozzle onto the paper. When the bubble collapses, a small vacuum is created which allows fresh ink to be drawn onto the printhead. This continues until the printing cycle is completed. The second technology is piezoelectric. Here, a crystal is located at the back of the ink reservoir for each nozzle. The crystal is given a tiny electrical charge which makes it vibrate. This vibration forces the ink to be ejected onto the paper. At the same time, more ink is drawn in for further printing. Now, both types of technologies work kind of similarly. The point is to push the ink out of the nozzle onto the paper, and that's what both of them do. The common process you need to know is as followed. This is the key bit. Pause the video to make sure that you understand the step. Data from the document is sent to the printer driver on your computer. The printer driver ensures that the data is in the format that the printer can understand. A check is made by the printer driver to ensure that the chosen printer is available to print. Is it already printing? Does it have enough paper and ink? All of that checks are done. The data is then sent to the printer, which is stored in a temporary memory known as a printer buffer. A sheet of paper is then fed from the main body of the printer. A sensor detects whether the paper is available. If it's out of paper, then it sends an interrupt back to the computer telling it, well, stop the printing because I've got a problem. If everything works out, the sheet of paper is fed through the printer. The print head moves from side to side across the paper, printing the image line by line. all the ink colors are combined in the exact amount which is needed to reproduce the color that's required for the printing. So at the end of each full pass of the print head, so this print head goes line by line, the paper is advanced very slightly so the next line can be printed. And this process repeats until the full page is printed out. Now, of course, if there's more data in the printer buffer, the whole process continues all over again until the entire print job is completed. And if for some reason you're printing like hundreds of pages and the printer buffer can't contain that data, it runs out. For example, you just printed 5 pages and then it needs more data from the CPU, it will send an interrupt back to the CPU saying, well, okay, my buffer is empty, feed me some more data. Because the printers are normally a lot slower than the CPU, buffers are quite useful for this particular process because they just fill the buffer and the printer doesn't need to go to the CPU for the data, it just goes to the buffer. So the printer can take its own time printing it. And once the buffer is empty, more data is filled in and this process continues to repeat until the entire print job is completed. So do pause this video and go through this particular process because you will need to remember the same type of process for the laser printer. So it's better to get to know the inkjet one because you can then tweak it slightly for laser printers. So laser printers are up next. They use dry powder ink rather than liquid ink, and they make use of properties of static electricity to produce the text and images. Now, unlike inkjet printers, laser printers print the whole page in one go. Inkjet printers print the page line by line. So their advantage is the speed at which they can print out large print jobs. For example, if you wanted to print out 2000 leaflets, it's better to use a laser printer rather than line by line inkjet printers. The dry powder ink is known as toner, so make sure that you know this technical term as well. So the applications for use are high quality printouts and high volume printing in color or monochrome, which is black and white, and they're normally used for producing large number of high quality flyers or posters for advertising, so really professional quality work. Their advantages are that they have large toner cartridges and large paper trays, but the major issue is that they're more expensive to buy compared to inkjet printers. So how does the laser printing process works? It kind of works the same way as the inkjet process. So make sure that you pause the video and understand these processes. Data is sent to a printer driver. The printer driver then makes sure it's in the same format as the printer or the laser printer in our case. A check is made for various different things. Is there enough toner? Is there enough paper? All of those kind of things. Is it busy or not? The data is then sent to the printer buffer. And here we deviate slightly from the inkjet printer. At the start of the printing process, there's a printing drum inside the laser printer, which is given a positive charge. And as the drum rotates, a laser beam is used to draw the image of the page using a negative charge. The drum is then coated with positively charged toner, which now sticks to this negatively charged image. A negatively charged sheet of paper is then rolled over the drum. So this positively charged toner now sticks to the actual paper. To prevent the paper from sticking to the drum, the electrical charge on the paper is removed after one rotation of the drum. The paper finally goes through a fuser, which is a set of heated rollers, and this heat melts the toner so it permanently sticks to the paper. At the very end, a discharge lamp removes all the electric charge on the drum, making it ready for the next page. And this process continues until the entire print job is complete. Okay, we're going to leave those printers aside and we're going to move on to 3D printers. 3D printers are primarily used in computer-aided design applications and they can produce solid objects which actually work. The solid object is built up layer by layer using materials such as powdered resin, powdered metal, paper, or even ceramic powder. On screen, you can see a 3D printer on the right hand side. Pause the video so you can study it in a bit more detail and understand its operation. There's a huge number of features here. They can come in different types of sizes. They can use additive manufacturing where everything is built layer by layer, which is a sharp contrast to the traditional method of subtractive manufacturing where you have a block of wood or metal and you carve it by removing material to make the object that you want. Additive manufacturing means that we're not wasting a huge amount of material, we're just only putting the right amount of material to create each layer, maybe a bit more for the support structures, but generally you save a huge amount of material this way. Now there are two types of 3D printers, direct 3D printers and binder 3D printers. Direct 3D printers use inkjet technology, so you got print head which moves left to right just like a normal printer. However, the print head can also move up and down because it's a 3D, so it doesn't just work in 2 dimensions, it works in 3 dimensions. It allows us to build layers of an object. Binder 3D printing is similar to direct 3D printing. However, the method uses two passes for each layer. The first pass sprays dry powder, like a laser printer, and the second pass, a binder or a fuser, which is like a type of glue, is sprayed to form a solid layer. Newer technologies are using lasers and UV light to harden liquid even, so we can create a wide range of diverse products. For example, food can be printed using binder 3D printing method rather than direct 3D printing method. So how do 3D printers operate? Well, the design is made using a CAD software. The finalized drawing is imported into some special software that prepares it in a format that is understood by the 3D printer. The 3D printer itself needs to be set up, and then once it's ready, the solid object is built up layer by layer, often up to zero point 0.1 mm thick, and this can take several hours depending on the thickness of the layers, the material that we use, and the size of the final object. The object is removed from the printer and is then prepared. For example, there might be some support type structures which need to be removed, and we might need to polish it and do all sorts of things to make it look like the actual thing we wanted to print out. And 3D printers aren't just used to print out just objects. We can even create things like prosthetic limbs, which can exactly fit the limb, and we can customize it to each person rather than making generic mass produced limbs. They make items to allow precision reconstructive surgery now. For example, facial reconstruction following an accident is possible. Manufacturers are looking at making wings and other parts using 3D technology. Fashion and art, 3D printing allows new creative ideas to be developed, making parts for items which are no longer in production. For example, there might be an old bike or an old car which needs a particular type of part. Nobody's going to be producing that, so you can 3D print it out. All of that's now possible. And of course, there is other things like food and organ parts which can be created as well. So make sure that you're reading around this area to know what the latest applications are. Okay, from 3D printers, we're going to move on to flat panel displays or monitors. Now, in the old days, you used to have the CRT cathode ray tube monitors, which you can see in the top right hand corner. And these are almost gone now. You can still see them around in some old hotels and places of work, but they're gone. Most monitors and TV sets these days are made using liquid crystal display, LCD technology, or LED technology. Modern display panels use OLED and even flexible OLED, which allows you to create flexible displays or curved displays. We'll look at all of that in a moment. So what happens with LCD technology? Well, the front layer of the monitor is made up of liquid crystal diodes, and these tiny diodes are grouped together in threes or fours, which are known as pixels. Three colors are grouped together using red, green, and blue diodes. So you've got tiny LED lights, which can just generate one color. Three of them are put together to form a pixel. Some systems use a fourth one, a yellow diode, and this is to make the colors a bit more vivid. Modern LCD monitors are backlit, therefore they use LED light technology, and this is not true for all types of LCD technology, but more and more these days use LED backlighting rather than a lamp-based backlighting. And the reason they use it because it gives better contrast ratio. LCDs don't produce any light of their own. LCD screens have to be backlit using LED technology. So this must not be confused with pure LED screens. There, the LEDs themselves are the light source, so you don't need a separate light source. So LED screens tend to be a lot more slimmer than LCD displays. So use of LED backlighting in LCD displays gives a very good contrast and brightness range. And before the use of LEDs, LCD screens used cold cathode fluorescent lamps, CCFL, as backlit lighting, and that meant that the displays were a lot more thicker. Think of CCFLs as tube lights, so imagine a strip of tube lights running all the way across behind your screen. That meant localized lighting wasn't possible. When LEDs are used, a matrix of tiny blue-white LEDs are used behind the LCD screen, so we can control individual pixels or zones of pixels instead of just having one whole row of pixels light up. That's enough about LCD displays. Let's move on to LED displays. An LED screen is made up of tiny light emitting diodes, and these diodes are either red, green, or blue in color. By varying the electric current sent to each LED, brightness can be controlled, producing a vast range of colors. Now, this type of screen tends to be used for large outdoor displays due to the brilliance of the colors produced, or nowadays on your phones. Recent advancements in LED technology have led to the introduction of organic LED screens and even micro organic LED screens, which are the premier of the current display technology. LEDs have become increasingly more popular because they have a huge number of advantages over older technology. They can reach maximum brightness almost immediately. They give a whiter light which sharpens the image and makes the colors appear more vivid. And the same light also improves color definition. Monitors using LED technologies are much thinner because there's no need for backlighting. LEDs last almost indefinitely. This makes the technology more reliable, and they consume very little power, which means they produce less heat as well as using less energy. Now, of course, we mentioned OLED, which is newer LED technology, which makes use of organic light emitting diodes. And these use organic materials made up of carbon compounds to create semiconductors that are very flexible. Organic films are sandwiched between two charged electrodes. So you've got a metal cathode and a glass anode. When an electric field is applied to the electrodes, they give off light, which means that there's no form of backlighting required at all. This allows for very thin screens. It also means that there's no longer a need for us to use LCD technology anymore, since OLED is a self-contained system itself. The diagram on the bottom right-hand corner shows how the different layers operate for an OLED screen. So do pause the video and have a look through that. So what are the advantages of using OLED compared with existing LEDs or LCD screens? Well, OLEDs give a brighter light than LED. The light emitting layers of an OLED are lighter, and these layers can be made from plastic rather than glass, which is used in LED and LCD screens. OLEDs do not require any backlighting like LCD screens. OLEDs generate their own light. Now, since OLEDs require no backlighting, they use much less power than LCD screens, and this is very important in battery operated devices such as mobile phones. Since OLEDs are essentially plastics, they can be made into large, thin sheets. This means they could be used on large advertising boards in airports, subways, and so on. OLEDs have a very large field of view, about 170 degrees, which means you can see them from a corner compared to all other types of display technology. So they are very useful when we create television screens which need to be viewed at multiple angles. And because of their flexibility and size, OLED displays can be attached to fabrics to create smart clothing or even create foldable phones, which are becoming quite popular these days. Okay, that's enough about visuals. Let's move on to sound. Let's look at speakers and headphones. Sound is produced from a computer by passing the digital data through a digital to analog converter and then through an amplifier. Finally, the sound emerges from a loudspeaker, and that's basically what the process is. Now, if you remember the input device, a microphone, vibration hits a diaphragm, which then moves a coil or a permanent magnet, which induces an electric current, which is then converted into a digital signal via an analog to digital converter. This process is the reverse of that. So the microprocessor generates a digital signal, which needs to be converted into an analog current. This current then passes over a coil, which moves a magnet, which then ends up vibrating a cone at different frequencies and amplitudes, which generates the sound that you hear. The rate at which the DAC can translate the digital output into analog voltage is known as the sampling rate. Hopefully you remember that from Unit 1. Let's look at speakers and headphones in a bit more depth. Speakers convert electrical current to sound. So when an electric current flows through the coil of wire that is wrapped around an iron core, the core becomes a temporary electromagnet. A permanent magnet is also positioned very close to this electromagnet. So as the electric current through the coil of wire varies, the induced magnetic fields in the iron core also varies. This causes the iron core to be attracted towards the permanent magnet, and as the current varies, this will cause the iron core to vibrate. Since the iron core is attached to a cone, which is made of a paper or thin synthetic material, this causes the cone to vibrate itself, producing the sound wave. In the bottom right hand corner of the screen, you see this in operations. Do take a minute to pause the video and study this diagram, but the process is pretty simple. It's the reverse of what is happening with a microphone, basically. Now, that's where we're going to draw the line for today. It's a really long lesson, so hopefully you took your time going through this. You should be able to answer the following questions as a result if you really understand the different types of output devices. You should be able to explain the operation of a projector, either an LCD projector or a DLP projector. You should be able to explain the operation of a speaker. You should be able to explain the operation of an LED display or an LCD display or an OLED display. You should be able to explain the operation of a laser printer or an inkjet printer. And you should be able to explain the operation of a 3D printer, how it works. So make sure you have at least 4 key points that you can easily answer for each type of technology. Hopefully the lesson made sense. If you do have any questions, as usual, please get back to me. Otherwise, I'll see you in the next one.